Hello everyone, and this time we're going to be doing example 9-11. Okay, this one is a bit different in fact that we went through shear stress for the past two examples, and we're going to be hitting on a different form of shear stress this time called punching shear. Now, punching shear has the exact same equation. We're going to still have that whole tau equals V over A, or sometimes it's shown as equal to load over area, but this time our area is going to be different. For the past few, it's been the area of a circle or the area of a rectangle, and in this time you might at the first think that it will be the same, but it's not. So what we're going to have is we're going to have a piece of aluminum right here, and that piece of aluminum is a 1/4 inch thick. So that's going to be 0.25 inches. What we're doing is we're going to be punching out a chunk of this. We have some punch device at the top, and it's going to be punching a hole straight through it. Pop! Out comes the hole. Now what I've said before, there you go. What I've said before is that when you're thinking about the area to use in this shear stress equation, it's always the area that you couldn't see before. It's the area of the cut. In this case, the area of the cut is this outer surface area of this punched circle. So it's not the area of a circle, it's actually more or less the surface area of a cylinder. So you see it's this area right here on the interior surface, which is round and has a certain height. So the area of a cylinder is going to be equal to pi times the diameter times the height. In this case, it gives us, this is termed thickness, which is 0.25 inches. And so it would be pi times the diameter times the thickness. So this is our area in this particular problem. When you hear punching shear, make sure you understand what this shape is that's being punched out, and look for the area that's been revealed. The area that's been revealed is the important area. Okay, so with that in mind, let's try some stuff. Or not. Now, you're watching a video. You can do what you want. So first off, we have our shear stress equation. It gives us a couple more things. First off, it says the punching operation is going to be with a diameter of 3/4 inches. So given that this diameter right here is 0.75 inches. So D equals 0.75 inches. And it says the ultimate shear strength for aluminum is equal to 27,000 psi. 27,000 psi. Ultimate shear strength is the shear stress you have to apply to cause it to break, or in this case, to punch through. So we rewrite our equation, and we have shear stress equals load over area, and we're trying to solve for the load. We know what the shear stress is, that's given in the problem statement. The area we can probably calculate. Let's use this equation that I gave you earlier. So area is going to be equal to pi times the diameter, which is 0.75 inches, times the height, which is 0.25 inches. And then from that, we get the area is equal to 0.589 inches squared. 0.589 inches squared. And then we can plug that into our equation. Now we want to find the load, so we need to make sure we solve for that first. So we multiply both sides by area, and what we get is the load is equal to our shear stress times our area. And so let's work that out. So load is going to be equal to 27,000 psi, or pounds per inch squared, times 0.589 inches squared. So I should get pounds at the end of this. What I find is the amount of force I need to apply is 15,900 pounds. That is a lot of force. But it makes sense, this was fairly thick aluminum. Or just punching straight through. Okay, So with that, what we've learned this time is that the area we have for our shear stress equations is not always flat. It can be a curved surface, like the surface of a cylinder. And that's usually the case when you have punching shear. We've learned that the punching shear equation is pi times the diameter times the thickness. And we also learned that we can calculate the required force if we're given the ultimate shear stress, which is the max amount of stress that it can take before it fails, or in this case, before it punches through. So I hope this made sense to you. If you have any questions, please email me or post something in the forums, and I will see all of you soon. Have a good day.